Hello everyone. So today I'm going to explain you about UJT. The UJT is a unijunction transistor. So we'll see the full form of the UJT is a unijunction transistor. As you can see, the basic construction. It consisting of a bar of a lightly doped N-type silicon. So with a block of a P-type material on the other side. So this the end terminals of the bar are the B1 and the B2, and the PP type block is named as an emitter. So this is emitter, E is an emitter. Okay, so this is the basic construction of the UJT, and you can also see the equivalent circuit of this. So as you have all studied in the first module that the PN junction, which is nothing but a diode. So this is the equivalent circuit of the basic construction of the UJT, and this is RB2 and this is RB1. So as you all know, the V is equal to IR. So that is a basic thing. So first now we'll see how exactly the UJT works. So as you can see, so when you apply the VEE here, so you're going to apply an VEE here. At that time, the current IE starts flowing. Okay, the current IE starts flowing and it starts to increase across the RB1 also. So what happens in the RB1 is the RB1, so resistance will get reduced. So whenever the resistance is less, at that time only the current flows, right? Okay, so next we'll see so this thing, the equation of this, so that is the V1 equation. As you can see, the V1 is equal to VB1 into VB2 into RB. So this is RB1. Okay, so divided by RB1 plus RB2. As you can see, so this is the so characteristics of the UJT. So as I told you, so whenever you start increasing or when you start giving the VEB1, the current IE starts flowing. So when the current IE starts flowing means the resistance will be so reduced. As you all know, V is equal to IR. So V is equal to IR. So V is equal to IR means what? So whenever, and also I'll just write here, V is equal to IR. So I is equal to V by R, right? Okay, means so whenever the current increases here whenever the current increases means the resistance decreases. So here the current IE is just flowing here. So whenever the current IE is flowing, the voltage is also increasing, and the voltage will increase to a particular point. After that, in the UJT, the voltage starts decreasing actually. Okay, so why so whenever the IE starts increasing, that is where when you just give, here you can see, so whenever you give the VEB1, at that time the IE increases, that you know. You can see the IE, so whenever you're increasing or whenever you're giving the VEB1, at that time the current is also increasing, the current is increasing, and the current increases to a particular point. At that point, so that point is called as a VP. So at a particular point, the current will increases or it will just shoot up. At that region is called as a cutoff region. So after certain point, the characteristics of UJT is such that the voltage. So whenever you start increase, so whenever the current is increasing, at that point the voltage will start decreasing. So that point is called as a negative resistance region. The basic funda is, you all know that, so whenever the current increases, the voltage should also increase. But in this characteristics of the UJT, the voltage is decreasing. So that's why this region is called as a negative resistance region, because it is not obeying the Ohm's law. So this is the Ohm's law, you all know, V is equal to IR. So whenever the current increases, the resistance should decrease. So that is happening. But whenever the current is increasing but the voltage is here, it is started decreasing. So that's why this is called as a negative so negative resistance region. So after certain point it will not increase, although you increase so whatever the voltage or the current, it will not increase. So that point it is called as a saturation so region. So here also you can see the IB2 has been set to 0. It is not increasing. At certain point it will increase and it will become constant. Okay, so this is the equation you can see. So that is what I told. The V1 is equal to VB1, where B2 into RB1 divided by RB1 plus RB2. Sorry, I've not written here properly. So whenever the voltage is increasing, the resistance is also increasing. So that's why this region is called as a negative so resistance region, because this should not happen, no. So whenever the voltage increases in the Ohm's law, the resistance should be less. But here in the equation, whatever the equation which we have obtained in the UJT, so whenever the voltage is increasing, the RB1 is also getting increased. So this region is called the negative so resistance region. So after certain point, the current becomes saturated. So that region is called as a saturation region. Okay. So this is all about the UJT. Okay, thank you.